Hello everyone and welcome to the third video on intersection of solids. In this video we're going to be taking a look at method number 3. So in previous videos we had on intersection of solids, the first one we looked at the limits method where we were dealing with basic prisms. The second video we looked at the elements method, so using straight line elements on a surface to find a range of intersection points between two solids. And in this video we're going to be looking at vertical sections method. Now, some questions are not just unique and they cannot only be solved using only one method. So the questions here, maybe they can be solved using alternative methods as well. But I'm going to do as I did. I'll take the same format as the last two videos and I'm going to just work through 3 examples of questions that can be solved using vertical sections as a means of establishing a full profile of intersection between two solids as we see here on the screen. What I'd like to start off with is this. I'd like to just start off by exploring what we mean by vertical section. So a section is just when you take a plane and cut an object, and then the plane that we take is vertical, just like this one right here. And as I move that plane in and out to different positions, so at every position that I stop and accept that cut, I've cut both objects, and even though these are two cylinders, the cuts are quite simple to draw, because as the cylinder here gets cut parallel to its axis, I just get a rectangle, and even though this cylinder is inclined at an angle, well, I still just get quite a simple 2 parallel lines going in there, and just they'll all merged in at that point right there, or along that line right there, which gives me a point of intersection above and a point of intersection below, and a range of points of intersection will give me a full profile, a line of intersection. This time around, usually when we look at section planes, we often think of horizontal section planes, but I wouldn't like to be giving anyone the task of drawing multiple views such as this one right here, where we have lots and lots of geometry involved in finding these freehand curves here. So we avoid at all costs any form of section views that mean that we need to be drawing any ellipse or anything like that. So we use, in this case, for a question such as this one, vertical section is a great solution to the problem. So let's go and just see how we actually make that work. First off, what I have done here on SolidWorks is I've split up the surface into 12 equal sections, and as I look down on plan, well, that's not really feasible to draw it as it is like that in plan. So what I will do here is I'm just going to project out my central axis of the object. I'll just project it out. I'll pick a position out here. I'm just going to draw a semicircle, that's all, because I'd like to bring some sort of organization and order to this. So a semicircle out here will represent a position for me to break up my view and get just some reference points that I can work with. So that's broken up out there. Like so. And there we are. Now, taking those points that I just found, and let's say I'm going to just number now as I go. I'm going to start by saying that the point up top here, so this top point is point number 1. Okay, so that will be a 1, and then 2 will be next. And again, we won't think too much into this. I'm just trying to break it up into manageable points, as we always do when we're dealing with circular objects. Usually we break them up into our 12 points. Just means that I can do this. That's 1 up top, that's 2 next, 3 right there on the outside is number 4. I'm going to just find that more accurately now in a second on my page. 3, 4, 5 is here, 6, 7, 8, 9, 10 is out there, 11, 12. And that's it for now. I'll just take and project 7 matches up, 1 matches up there on top. What I would like to have here is I'd just like to maybe find the center of the object here so that I can get my, what would that be, 4 and 10. I need those two. So And if you have drawn this fully out in a worksheet, well, you're going to find that you'll already have these centres, so you won't have an issue. I'm working with a worksheet that's already set up, so I need to find my centre and just bisect that portion there between 1 and 7. And I'll find my centre in plan and just right there in elevation. So that's just a little starting point. This question is set up with this cylinder here at an incline of 30 degrees. So I'll just draw the central axis of the object. There it is. And we're ready to get going. Now, where do we start? Well, what I've simply done right now, I think once again, without overcomplicating what happened here, that just gave me some reference points so that I can break this up into 12 portions. What I'm going to start with is this. First off, the easy points. Number 1 goes in and hits on the extreme edge of the cone, of the, cylinder. Number 1 goes in, hits the extreme edge of the cylinder right there. So that's an easy one to get started with. 1 up top goes in and hits the edge. So that's the extreme top of this object. Just stop it slightly short there. Number 7 down below also goes down and hits the bottom edge. There we go. So that's the first 2. There's number 1 up top, number 7 down below. And does that look like what's happening here in the elevation? So number 1 up at the top, number 7 down below, well, they just go in and they hit the outer edge of the object, in this case right here. What's next? Number 4. So 4 and 10. Now what we're going to find here is that because it is located centrally along the object, the curve to the front and the curve to the back are going to match up. So I'm just going to ignore all of my points at the back, because the hidden detail at the back won't be seen because the solid detail here will take precedence. Number 4 though. Number 4 here, as we can see, and this is a bit like our limits method from before in a sense, number 4 goes in and hits right there. So that's the end of the line number 4. But what else can we say about it? Well, we could do this. Okay, this is what we need to start thinking of for these questions. I'm going to section the object along number 4. There we go. That is section number 4 right there. What does that look like in the elevation? Well, first of all, what does it look like in my model here? I'm going to turn on my section plane. I'm going to use a vertical section. I'm going to flip the direction, and I'm going to bring it right out here to number 4 at the front. I'm pretty sure that's close to number 4, and let's turn it up there to meet the elevation. And there we go. There's a section plane at number 4. The red cylinder is sectioned like this. That's what the first section looks like. It's there in blue. The point of intersection that lies on that section plane, it goes from 4 down to hit. So from 4 down and it hits. And there we go. That's point of intersection number 4. There's number 1 at the top, and there's number 7. And as you can imagine at this stage already, we're doing a little bit more repetition this time. Let's go back to plan. We'll turn our section view back on again, and we'll change it, and we'll bring it back here. What are my next 2 points? 3 and 5 are lining up there, so I'll bring it back as close as I can to 3 and 5, and we'll drop it there. So a section plane through the objects at 3 and 5. I'll pick a different colour here, and we'll section again. So at 3 and 5, I'm going to section plane through both objects. What does that look like in the elevation? There we have it. So let's find point 5 in the elevation, which is there, and we'll find point 3 in the elevation, which is there. So we have, I should keep my colour scheme going. We have, what's that? That's 3 up above, and that's 5 down below. The cut is going to be parallel to the central axis of the object or the edge of the object. So in this case it's given at 30 degrees. it cuts 0.5, it cuts 0.3, but what else does it do for us? I should draw that a little bit heavier there. What else does it do? Well, it cuts the red cylinder, cuts both objects. So the red cylinder that stands up gets cut. And gets cut. Now, what does that give me? So where the green cylinder cuts come down from 0.3 and 0.5, and where the red cylinder cut goes up and hits, that gives me 2 more points on my intersection. It gives me 0.5 down low and 0.3 up above. If I just turn this to 3D view here for just a moment, hopefully we can see clearly what's happening there. So as we section through at 0.3 and 0.5, our resulting cut on the green cylinder is a parallel line to the extreme edge or to the axis, and our resulting cut on the red cylinder is parallel to the extreme edges or the axis. Where the cuts cross give me some points right here and here on the profile of intersection. Let's get back down there to plan again, and let's drop in a new section plane. Next section plane, I'm going to go into points 2 and 6. There we are. I'm at 2 and 6. I'll accept that. I'll cut the objects. It takes a little bit of visualizing here. It takes a bit of imagination. You know, you have to really commit to these questions, I think, to be able to imagine what's happening. So 2 and 6 sections there in purple. What does that look like? Well, I need to first of all, find 0.2 and 0.6 up there in the elevation. I need them. There's 2. There's 6. 2 there. And 6. What are my resulting cuts? Well, once again, if I turn on my elevation, well, on the green object, it's parallel to the outer edge or parallel to the main axis. So parallel to the main axis or the outer edge, and it cuts at 6. It cuts at 2. My red cylinder then, the one that stands upright, where does that get cut? Well, it gets cut right here. And it gets cut all the way over here. And after all of that, I need to have a quick look again, look for my points. Where does the purple cuts cross? Right there at 0.6, and up right here at 0.2. And that's this question finished. We just have to, that's the real thinking part finished. We just have to join the dots, and then that will be it. I can heavy in what needs to be heavy, I can join the dots, and I will be done. So I know that from 7 down to the ground is heavy, and from 1 up to the top. All of this edge along here remains untouched. The back edge of the object here. And the top. What else do we need? Well, we need to just drop in our freehand curve. And that's it. There's no more to this drawing. We have used 3 vertical sections to solve this question. It's quite a fast method. There's nothing really majorly confusing about it. Once you get to grips with it at the beginning, it doesn't get any harder than that. So our 3 vertical sections used to find the full profile of intersection through the objects. So there we go. That's this first question finished. I'm not going to delay adding the colour here. I'll just add a little bit of colour, keep it going, keep the video going nice and quickly, and then we will move on to our next question. And there we have that finished solution. Little bit of colour added very, very quickly. Just, I think it helps to finish the object. It helps to see the lines of intersection, profiles of intersection, and so on. Now, nice easy question to start. Let's move on. Let's get 2 more done, and we'll up the difficulty a little bit as we go. Here's our second object, our set of objects, and as you can see, we're dealing with a blue cylinder here and this green triangular prism that is intersecting along these curves. So our profile of intersection this time is going to be a set of 3 freehand curves, and we can see the one here at the back of the object, and the third one down is visible, but this bottom flat surface as it intersects and wraps around the cylinder. So 3 freehand curves here, but we also have specific intersection points where the 3 edges of the main edges of this triangular prism intersect and pierce the surface. So that's going to be our challenge. First thing I'm going to do here on paper is actually start forming the end elevation. So the plan is already shown, the elevation is partially shown, and I'll start forming the end elevation now. I'm going to just heavy in a little bit of the main elevation here, because as we can see the object is only intersecting on the right hand side. It doesn't show it coming all the way through. The top line of this, the top surface, doesn't get any intersection at all, so that remains unchanged, and the right hand side will be changed. So that's all I can do over here. Then if we just take the look at the elevation there, we see the top point, second out of the front, and the bottom one down below. So I might just number my 3. So point 1 is up at the top, point 2 is out at the front, and point 3 at the bottom. That means point 1 is up at the top, 2 out here at the front, and 3 at the base, at the back of it. I'm going to project them to my end elevation. And from my main elevation, and I might just draw the prism as it is here, this triangular prism. So line up my points. Point 1 is up top, point 1 is up top, point 2 here at the front of the object and at the front, and point 3 down at the bottom, the back of the object here, just there. And there we go. So where do we get started now? Well, I think the easiest thing to start off with is just some of the actual intersection points. So before I get into the real detail of these profiles of intersections wrap around, I might just start off by just finding the first 2 intersection points. Maybe just this one here at the front would be my first one. It's the closest point to me here in plan. I'm going to get going with that one. So much like the last question, I'll start off by inserting And I don't really need to here. This is actually easier than I'm making it now, but just to reinforce the method. That's my first vertical section plane right there. What does that look like? So if we look down on top of the object right here, I'll turn on my section planes, flip the direction, and I'll bring it out until I'm on that front edge right there. And that's what it looks like. So we've cut the objects. As I look up at the elevation, well, there we have it now. Just cut slightly too far back, but in theory we'll go with it. We cut the object, but this time instead of drawing a full section plane each way, that's cutting number 2 there. So I get the exact position there of the intersection point for the edge 2. That's edge 2. Oh, I have a feeling that 3, if I just go back down to my plan, 1 and 3 are both around the back of the object. So if I want to go sectioning those, they're going to be part of my hidden detail at the back, but I might as well just drop them in. So that is point 1 up top. I'll section it at that point, and we'll view what the elevation of that section looks like. So a section through at 1 is there, and the elevation of that section should give me the intersection point at 1. So the elevation of that section gives me the intersection point here at 1, which is around the back of the object. Now that means that I can, from 1, I can go heavy to the line, and I'll have to just try and do a little bit of hidden represented there going around the back of that line. Point 3. This time I'm not going to use colour, I'll just go straight with my pencil. 3, if I section, is here. Or we could argue that I'm just using the limits method, which I am. So 3 intersects the surface right there, and there we go. And again, it's at the back of the object, so it's going to be solid as far as the edge, and then all the way into the intersection point it's going to be hidden just like that. So that gives me point 1 is above, point 2, and then point 3 all the way around the back. If I turn off my section view now for a minute, and we look at what the elevation is looking like. So point 2, if I turn on my hidden detail just to make sure we've got this, we have our point 1 here up top, we have point 2, and we have point 3 down below. Now I wouldn't worry about the fact that 2 appears to have gone a little bit further forward than 3 here, unlike my page. That's no problem. As I said, these models are not an exact representation of the question, just something near. Okay, let's start working on finding some points up along. I'd like to start finding some points up along here. I need to get multiple points so that I can join up these freehand curves to represent the profile of intersection. To do that, if we look back down again on our plan, what we're going to do is this. We're going to just insert some section planes at various positions. So we already have point, that is point 2 there at the front. I'm going to just move up a little bit in along. We'll accept the plane, and we'll see what the elevation looks like at that point. So once we do that, we'll actually end up getting a point on the line of intersection here up top, and a point on the profile of intersection down at the bottom. One vertical section will give us 2 points in the curve. The end elevation that I constructed, well, it just looks as you'd expect. It's a section through both objects, and it's on the end elevation. I'll be able to see some more detail here. So I'll be referencing now between all of my views when I'm doing this part of the drawing. So let's get going on that much. Let's see what we have. Now, where do we put these planes is the next thing. You put them anywhere you want, and you put as many as you want in there. I'm just looking at this now, and it's looking like 50 mil. Now, I'd be tempted to go 10, 20, 30, 40, 50, and then maybe about 1 there halfway. Did I measure them really exact? No. Do I need to run off with an angle and equally divide up my line? No, certainly not. So we can just drop in the planes wherever we see fit. and then I'm going to number my planes there. If I have enough colours, I'll just add a different colour. I might actually use lettering here now, so that it's just different to the 1, 2 and 3 I already used. So that's plane A. In brown I'll have plane section B. In purple here we'll have section C. In orange we'll have section D. And finally in red, A, B, C, D, we'll have section E. So 5 sections, vertical sections being put through this object to try and find multiple points on our freehand curve. Maybe I don't have enough yet, maybe I have plenty. We'll see as we work along. Let's get going. Section A. So section A here cuts the 2 objects. Section A there. That is quite close to what we can see here on the model. That's what it looks like in elevation. I can draw the section straight away there on the blue object. That's quite easy actually. So it's just projected straight up there from where the pink line or my vertical section cuts the main cylinder. So that's one side of the section view. And the other side of the section view. That's the pink section as it appears there in the elevation, cutting one object. Now I need the 2 lines here where that same section plane cuts the green triangular prism. So let's go and search for those 2 points. Where do I find them? I need the A, the one that's up top, and the one that's down the bottom. I need those now. And where can they be found? Well, they can be found over here in the in view. That pink section plane as it's represented in plan looks like that in the elevation. Okay, pink section, it's a vertical section plane right there. That means that I can project over the bottom point right here. So that's sectioning through the base of this guy. And I can project over from the top point. And that's sectioning the top. And there we go, we get our first 2 points. It's going to be a lot of repetition going on here again. So the curve goes from point 3 up to A, and it goes from 2 up to A, that's on the upward curve, and from 2 down to A on the downward curve. I'll call that A on top and A1 down below. So we have point A here up top, and I'll just call that A1 down below. Does that look right when we look at our elevation? So as it turns here to the elevation, we're going to just keep an eye on this point right here as I turn off my section view, and it joins back down to 2 and back down here to where A1 is going to be down below. Looking down the plan again, turning on my section views again and pushing it back through the object as far as where point B is. You don't have to draw the second side because it's not coming out this side. So I'm just going to work on one side only at the moment. And that gives me the point B here up top, and I'll just call this B1 down at the bottom. So that's where the brown section right there is going to show me in the elevation my next 2 points of intersection. So right there, point on the curve of intersection, and right there. Let's find them. And again, we'll simply find them by completing this section cut by projecting it across and in from B, project it across and in from B1. And there we get point B, and there we get point B1. C is next. In the elevation. And project it to the end elevation. That gives me point C up top and point C1 down here on the bottom profile. And that can be taken and projected over onto the section. So C1 at the bottom and C up top. C up top, C1 down below. Now, before I just start forwarding on this nice and quickly, I have one more point that I really want to have a closer look at, and that is through the center of the object. So which that will be around there, roughly through the center of this object right here, through the center of the cylinder. That's the next point I want to take. Now, I'm going to add no color for this one. I'm just going to use the pencil for this one. The central axis of the object is here. Okay, we'll take that one as a section. I'll project it up. And I'll see where the points are that are hitting right there. That's the central axis through the object. The points it's hitting are right there. And there. What are they? Those 2 points have to be bend points. Because it's taking its way around, hitting the outer, the extreme edge, and it's wrapping from the front around to the back. So that is BP1. And that one there is BP2. Now you could argue that they are not actually bend points because it's still part of the same profile all the way through. I'm going to label them as bend points because I think that usually our view is here in an elevation or in an end elevation, and we're looking at where do we go out and change direction and go back into, and where do we go from solid to hidden. So I just think for continuity we label them as bend points, and the BP1 is up here at the top on the extreme edge and BP2 is down at the bottom on the extreme edge. So that gives me, there is BP1 and right there is BP2. On that same principle now, what we also need to realize is this, okay? Everything behind those points is hidden, everything in front is solid. That means that them points are the last thing you see along the cylinder, below and above. So that means that I probably shouldn't be doing this yet. I usually don't like to start freehanding until I have all of my points, but just for the sake of this being one of our earlier examples, I'm going to do this. That much is what I can see of the green triangular prism to the front, at the top profile of intersection, and right there on the bottom profile of intersection. So that's my green prism. Now I'm wrapping around the back of the object here from the bend point, going from the bend point up to the intersection point at 1, and I'm going to go from the bend point all the way down along to the intersection point at 3. I'll do that by just continuing on with my vertical sections. So point D is next. And section D in the plan. do we get our points now? These sections are starting to run very close to each other. But I'll just get a point just in off the extreme edge there for D, and just in off the extreme edge there for D. And that would be it for my top portion. So we need to have a close look at this. We're going from 2 to A, B, C. We're going to our bend point, which, as I said, is not really a bend point, but we'll call it that because we are wrapping around the edge and coming back in. But we're going to that extreme point, D, and up to 1. So 3, A, B, C, bend point D, and up to 1. And we'll smooth, very, very easily draw it first, and then we'll go over it and make it hidden detail. So that's the total front top curve done. And let's see, does that look the same on the model here? So we're going up, along, around the outside external point and back in to just right here. Now I'd like to finish off my bottom one right here. So what do we have? On the way from the bottom one is 2 to 3. If we look at a 3D view of that and see what's happening, it's the bottom profile is all the way from 2 all the way around and on to 3. So 2 gets me on the way to 3, A, B, C, D, and then we could have point 1 there as well. We could use that as a section plane, E and 3. So I need some more. I need more to happen right here. So what will I do? I'll put in section E. Section E, right there. Project it on over. We need it in the elevation. Project it up. That red section E needs to be shown over here. And that gives me point E up top and E1 down the bottom. But there's a big space there. On the way from 2 to 3, there's a big space here. I might need another section plane there, but for now I'll just find those points and see how it's looking. So on the red section, which is just here to the right of the pink one, I get point E1 down below and point E up top. Now I actually think that is probably, that's okay. We can do that much going around here hitting E and D. That's no problem. We can carry that much, no problem, with our freehand sketch. Up top might be different, or we might need some extra points there. Now that's the bottom point wrapped around to the back of the object right there. Now up top though, as I said, where are we going now? Well, from point 1 I want to go all the way down through E and on to point 3. So it has to wrap all the way from 1 through, where's E is there, and down to 3 here. I definitely need some more points along the way. I can't be freehanding that much of a space right there. So where should I put more points? Best place to see where to put them here is in the end elevation. So where should I put? I have a section at 1, I've that found, I've 1, I've E, and I've 3. Well, I'd like to maybe find one more here in the center, right there, and one more here. So that we have 1 to this point to E, this point to 3. I've used all of the letters from E to F, or from E, sorry, up to E, so I'll just go with, that guy has been F and G. Now we'll just be a bit careful after when we're joining the dots together, of course, but there's our sections. Section F and section G. I'm not going to worry about the bottom points now because I think that we were fine there. We didn't need any extras there. It's just F and G, the top points. So I project them across. F and G. I need to bring those two sections down to plan. I need to draw those sections as they appear there in plan. And if I just label them now, I don't, no mistakes at this stage. We're gone too far to be making mistakes here. That is section G right there, and then section F is here. It's F and G, and that same vertical plane right there cuts F here. And where F crosses F, we get 1 point in our section. And finally, where G, that vertical plane that cuts the triangular prism at point G, also cuts the cylinder right here. Right there is point G. All that's left is to join the dots. So 1 to F, 1 to F, 1 F, E, G, 3. So 1 F, E, G, 3. It's getting busy now. We won't make any mistakes here. We'll try our best not to anyway. And we'll just have a look at what we're seeing here. 1 to F to E to G to 3 should be giving us all of the points necessary for this profile of intersection right here. Again, if we're just any bit confused about why I'm doing this, well, it is this wraparound profile that's completely hidden here at the back of the object. So let's go for that one now. Sketching it lightly first of all, really, really lightly, and then going over it and making it hidden detail. And there we have it. That is the complete question here. So our second sample of vertical sections being used to solve the intersection of two solid objects. Not an easy question there now to visualize. There's a lot of repetition, but there's also quite a bit going on here in the elevation. I'm going to just add some color here and just very, very quickly add the color because I'd like to really be able to see this wrap around just like we can here on my computer model. And there we have our finished drawing. Just a really quick little bit of colour added there to help visualizing it, so we can see the wrap around to the front. And I think once again the colour always helps with seeing why does it go from our solid detail back to our hidden detail. I think it just always helps with visualizing these and making sure that everything you've drawn looks correct. So a range of vertical sections, quite a few of them used this time. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 vertical sections there in total used. Or you could argue that there's actually 11 also between number 3 and 2 there. 9/11 vertical sections used to find a range of points along the profile of intersection of this triangular prism into the cylinder as shown. One final question to do in our vertical sections method. And our final drawing. So vertical sections again need to be used here to find the profile of intersection between this cylinder that's intersecting this square base prism at an angle. There's going to be some turning points of course involved here as well, because we have our cylinder coming back, wrapping around this corner and going around the back of the object. So what do we need to do? First thing that we'll do is this time, because we don't actually have an end elevation, we don't need to project any extra views, we just get started as it is. I'm going to start off by just heaving in what I can here in the elevation. I know that everything to the left of here really is untouched by the intersection, so I can start off by just heaving in some detail. The top of the object is also untouched, as we can see in the model here. Top is completely untouched, and as we look in at the elevation, we can see that the central line through the square base prism and the top and the left and the base remain completely unobstructed. Now, I'm going to just start by just numbering here in plan. I'll start off with point number 1 up top. I'd like actually to find the center here, proper center of this, so I'll just leave that at the moment, and I'll go to 7 out here, and I'll just bisect what's remaining here. And along the way there, I can split that up, and I'll get 0.4 out there at the front, 1 to 4 to 7, 8, 9, 10 at the back. So I'm just taking our usual method here of numbering, but this time, instead of drawing this true shape as a circle anywhere, I'm just going to guess some positions and just go with any random positions at all for some extra points, and it really won't matter where I put them. I'm going to just look out along my line there and equally space them, okay? Or maybe the numbers are working out quite well. It's almost 36, so if I just go 12 and 24 there for 2 section planes, that'll work just fine for me, because I can just do this. Here's the 12 and the 24, approximately 12, 24, and I get 1 down to 2, 3, 4, 0.5, 0.6, 7. I'd like the same ones up top. I'd like the very same instances up top as I have down below. So I'm going to just take my distances out to what's going to be my first section plane, and I'm going to just move them back and out to what's going to be my second section plane, and bring it back. Again, this just helps with the efficiency of drawing. Now, it's not really part of the method. And keep numbering: 7 to 8, 9, 10, 11, 12, and 1. So I have just some broken up points there, and along each point I'll be finding where they intersect with the surface, and I'll be doing that using my vertical sections method. Now, let's get started. So first off, what's the vertical section look like through this object? We'll be starting our vertical sections in plan, where the vertical section appears as an edge view. So let's drop in section plane, we'll reverse the direction, we'll bring it out here to the front, and there we go. That's our first plane. First plane, through at point 4, starting at the front, which has to be solid, and working our way back along. So the first plane cuts at point 4, and I'll go with just a colour scheme here for the first couple of points. We'll go with red for the first plane. What does that look like as I look in at the elevation? Well, it's just 2 vertical lines through my object. So point 4 is along there someplace. The left side doesn't matter. Where's point 4 in the elevation? So I need to just project all of my points up, of course, now. And while I'm here, I might just project everything up, so that I have something to reference from. Because I mirrored everything through the axis, 6 and 8 there will line up, you know, so it's kind of handy for me. Saves me a bit of work again. Keep your drawings organised and efficient. That is 5 and 9. There's 5 and 9. I should put them in red as well, make them a little clearer to see. 5, 9, 6 and 8. What's down at the very bottom is point 7. Up here in the middle is 4 and 10. Some more to add then. That is 3 and 11. 2 and 12. And point 1 up top. So we have 1, we have 2 and 12, we have 3 and 11. And that's all my points. This time, do I have an angle? Is it 30 degrees? It is actually, it's at 30 degrees again. Would it matter? No. If it was at 35 or 40 or 38 degrees, anything else, I'd just grab my adjustable set square, my adjustable set square, and set up with the angle of the extreme edge or of the central axis, depending on what I'm given. Now, back to the actual drawing here. As we can see in my model view, I've just gone back ever so slightly too far there when I dropped in that plane. So I'll go once more, I'll drop in the plane and bring it out one little notch. It's very, SolidWorks is quite sensitive with these, so if you go any little bit too far, yeah, it's revealing a cut on both objects, but I'm just going to take it that that's not there for now. What cut is that? That section plane goes through point 4 and cuts the square base prism along this red area, which is here, projected up. There's the red cut, and the cut is number 4. So where it's just coming in contact right there, that gives me an intersection point 4. What's our next one? Next one is a vertical section cut that gives me 5 and 3, both of them this time, which is handy. That's the very same as getting our plan here, moving our plane, taking it back along until we reach 5 and 3, and then seeing the elevation again. So first off, where does it cut the prism? It cuts it up along there. Where does it cut 5 and 3? Parallel to the axis. Gives me 5. Parallel to the axis. Gives me 3. Next up, 2 and 6. Cuts the object. Where does it cut the prism? Exactly here. And that is points 2 and 6. And there's going to be 6 right there, and 2 here. Moving along, 1 and 7 is next. 1 and 7, right there. Cuts the rectangular prism here, and that's 1 up top and 7 down the bottom. Moving along again. Well, where am I next now? I have 12 and 8, but I also have this point here, and that point has to have some significance. What significance does it have? Well, if we look at our model here, I turn off the section views for a minute, and we look back at our model. Well, we can't see it in this view, but what if we move it around? Can we see it from the back view? Just about, or if I just move it down one little notch, we get it here. That point right there defines our bend point top and bend point at the bottom. So they are going to be significant. They are important. Let's find them next. We'll just go with the pencil for them. Through the object, right through the center axis right there, bisection. I need to take that section up until I hit my object. Right there. and right there. Why am I doing that? Well, I'm doing that because that's what the section plane would look like as I section this guy off and go right up through the center point there. And I'm looking at the elevation. I need to see the section plane as it comes down through. So that's what I need next. I'm gone back behind point 1, so it's after the cylinder was appearing at its largest here at 1 to 7, so full size at 1 to 7, but now it's after going down and going a little bit smaller, which suggests to me that I can see everything up to 1, I can see everything down to 7, and from there back it's hidden detail. So we'll have to keep an eye on that one as well. What do I end up getting? Well, I end up getting bend point 1 and bend point 2 will be the 2 points that I will get right now when I project in. Where's the edge of the object? Where is it? It's here, isn't it? So when I project in right there, I get BP2 I'll put on the bottom. And when I project in up here, I get BP1 on top. So there are my 2 bend points by taking another vertical section through the object, finding the points on the outer edges right here, projecting them up and bring them back in. So I'm just basically showing another section plane right there. I'll continue on 8 and 12. And I'm starting to run out of colours here. 8 and 12. Sectioned on the prism. That's what my section looks like. Where is 8 and 12? Well, I think they're going to be lining up with something now. I'm doubling up on everything. So 12 is in line with 2, and that's on my blue section. So in from 12, there we are. Point 12, and 8 is the second one on my blue section. In from 8 onto the blue. There we are. Next is 11 and 9. Hopefully this can be seen now. We'll go over yellow. 11 and 9. Cuts the prism. And it is in from 11 onto the yellow. In from 9 onto the yellow. The last one that remains here looks like number 10. And I'm really running out of colours now. I think I have one, yeah, brown here. So, number 10, sectioned and projected. Now where's number 10? Let's spin along. And there we go. Now, there's a lot of points there on that model. I'm going to just take a look at the 3D here. We'll turn off the section view and we'll turn on hidden detail and see if this starts to make sense for us. So we're looking now at this intersection right here along the front first of all, and then we'll go with along the back. So we're looking along the front from the top point, which is 1 up top, being solid all the way down to the bottom point of the cylinder, number 7. We're going up to the bend point and around the back. We're coming out to the bend point and around the back. Let's get going on that much. So from 1 through 2, 3, we'll have to go 4, down to 5, 6 and 7. While I'm here, I'm going to keep going up there to BP2, but all light, still all light. From 1, I'm going to go all the way out here to BP1. I'll take my set square and I'll heavy in the edge 1 and the edge 7. Just heavy in the end of it while I'm here. And as always, we go heavy to the edge and then hidden down to bend point. Same here. almost impossible to do a hidden there. Time to add some weight to this freehand curve. And then we are hidden, up and hidden out here. Our next one, our backing curve right there, goes from the bend point down to 12, 11, 10, 9, out to 8 and bend point. So let's try and get it relatively smooth. With your freehand, lighten it off if you need to, just like I'm going to here. Lighten it off that little bit and then dash it. And there we are. Some colour to add to this. And there we have the finished drawing. So now we have 3 more examples worked through here on our third method of completing these intersection of solids questions. As you can probably see, especially when you bring in any cylindrical or conical objects, the amount of repetition is incredible. Like you really, if you understand the basics, you really are just repeating for a range of points to bring you around the profile. Then you'll have your odd little turning point or bend point dropped in, and you're back to another range of points again. Following the story as well is another big part of this, of course, in that you need to be able to go from 1 to 2, and also when you are sketching here, and I should have just added a little label in there for the bend points as well, down in plan. So where was BP1? BP1 was above between 1 and 12, that was BP1. As it projected in along, of course, was BP1, and it was also BP2 where it projected in. So they were just the 2 extras that were shown here. But that is the whole principle of the method of vertical sections, to find the points of intersection required to look out the full profile of intersection for these particular questions. Next we'll be moving on to the 4th method of solving these questions. We'll repeat again 3 more drawings in the tutorial, and hopefully you'll find that useful. I hope this video was helpful. Thanks very much for watching.